Hello guys, in this video I'm going to show you how to solve minimum window sort problem. Minimum window sort problem, right? So given an array, find the length of the smallest subarray in it, which when sorted will sort the whole array, right? So for example, we are given this array. So what is the size of the smallest subarray, which when sorted we sort the whole array? Explanations: when we sort only the subarray here from 5 to 9, the whole array will be sorted. So let's try to do it manually here. So let's say 1 and 2 will stay the same, 12 will stay the same. We will do the sort for this subarray. So it will be 3, 5, 7, 9, 10. Alright, so with this is sorted, the whole array is sorted now, right? So how I want to solve it here? Your initial idea might be to start from left and right and to find the first unsorted number, right? Then everything that is between will be what we need. So let's try to validate the idea. So probably wanna start from, alright, we can do it down here. It's the same right here, right? Okay, when I go from the left and go from the right, find the first that is unsorted, right? So 1, by unsorted I mean we must have two numbers, right? Two, we must compare the current number with its next number. For example, 1, its next number would be 2, right? We compare these two. So 1 less than 2. So this is still a correct order, right? Because this array, like after sorted, it will be sorted in ascending order, right? So go to 2. 2 compared to 5 is still less than 5. So here we still good. We move to 5. Now 5 should be less than its next number, right? But here 5 is greater than 3, right? So we stop right here and we do the same on the other side. Start from 12, compare it with its previous number, which is 9. It should greater than its previous. Okay, so 12 greater than 9, so we're good. Move to 9. 9 is should greater than its previous number, but in this case it's less than 10. So we stop right here, right? So essentially find we found from the left and the right two first number that are in a incorrect positions, right? So as I said, we can try to sort these subarray, and as you can see, 1 and 2 will stay the same here. 9 and 12 will stay the same as here. Sorry, 12 will stay the same here. We do the sort from 9 to 5 to 9, and we end up with this 3, 5, 7, 9, 10, right? And after sort these subarray, as you can see, we have the whole array sorted. So you might think that this will be the solutions, but let's take a look at another example here, right? Another array. Okay, we do the same. We find the first number that is in correct positions from the left. 1 compared with 3 is less than 3, right? So it's good at 1. 3 compared to 2. 3 should less than its next number, but here it's greater than 2. So we stop right here, right? Do the same on the other side. 10 greater than 7, good. We move to 7. 7 greater than minus 1, good. We move to minus 1. Minus 1 is not greater than 0. So we stop right here. So we do the sorting inside here. So we do the sort thing inside here. We end up with minus 1, 0, 2, and 3. And as you can see, even we sort this inner subarray, we end up with the whole array is not sorted anymore. Right? 1 here is greater than minus 1. Alright. So how do we handle these situations? Right? So you should you can notice that here we by doing these kind of operations where we trying to find the first number from the left that is out of order and first number from the right that is out of order, we did a great job of dividing our initial array or original array into 3 sections, right? The let's say let's call it low, and here is high instead, right? So all the number that is after the high is sorted, right? Because we find the first number that is unsorted, so all the number on the right should be sorted, and all the number that is before the low will also sorted, right? So if we can find the max and the means inside if we can find the max and the mean value of the this subarray that constrained by low and high here, right? Then from the mean and the max we can start checking from the every number that is on the left of the low, and wanna stop at the point when I use the mean value, right? We expect that the mean here, the mean of this subarray should greater than any value uh, greater than any numbers that is before the low, right? And the max of this subarray should be less than any number that is come after the high in order for this whole array being sorted when this one is sorted, this subarray is sorted. Because when this subarray is sorted, the mean will be here and the max will be here, right? So the only thing that is left to be done is to check every number that is come after high, right? Every number come after high wanna include the number that is less than the max here into this subarray, which in the end will be the minimum window sort. Right? We do the same here. We go from the first number that is before the left here, go all the way to the left, right? And when we want to include any number that is greater than the mean value of this subarray. The mean value of subarray should be here, right? So any number that comes before here should be less than the mean. All right, this could be a little bit confusing, but it will be clear when we code it out. Okay, let's list out a couple of things we need to do for this problem. Okay, first is wanna go from the left, find the first out of order number. Go from the right, do the same, find the first out of order number, right? Then what is next we done? Wanna find the max and mean. Uh, this will be at low index, for example, and here we call it high. And wanna find max and mean between low and high index, right? And wanna go from low -1. We start from this number and include all the way to the left, right? Wanna include any number that is greater than the mean value of the subarray. Wanna stop when um, current number is less than mean. We do the same, go from high +1 all the way to the right, include number that is less than the max. Stop when the number is greater than the max. This one I'll explain later when we get into the part. Alright. Firstly, go from the left. So let's say let's start low at 0, right? So as long as the number at low is still less than array number at low +1, which is the next index. If we choose we want to move ahead here, right? Else we stop. But here we are checking low with its next index, number at next index. But we must check if this is still within the array range, right? Only if low +1 is still less than within the range of array. Okay, we do the same with high equal to the last index, which is array of length -1. So as long as the high no, as long as the previous number, which is at high -1, is still less than high array at high index, and here should be array instead. Same here, we need to check if this is still within the range. If high minus 1 is still greater than or equal to 0, which is a false index, because we go from the right all the way to 0. High minus minus. Okay, so here we finish these operations. So here we need to do a bit of check, right? What if what if what if we have a case where it is like sorted, it is sorted in ascending order for the whole array. What would be the low and high in this case? The low will run all the way to the right, and the high will run all the way to the left, right? So in this case, the smallest smallest window here would be psi of 0. Right? We cannot find that window because it is sorted by default. So in this case, if the low is greater than or equal to high, probably I want to return 0 here. Okay, find the max and min between low and high. Okay, so simple, we just use a for loop here for let I equal to low as long as I less than or equal to high, I plus plus. Right. Now define max and min here. Min will be initially will be a infinity, which is a very large number, and max will be very small number minus infinity. So inside here, we're gonna update the min and max. Right? So min will be whatever that is smaller between the current mean and the current number, which is array at index I. Same here, the max will be whatever that is largest between the current max and the current number. So after this loop, we have min and max of the between low and high, right? And initially, the smallest window that we need to find, smallest window will be side of the sections between low and high. Right? So will be high minus low plus 1. So we will try to expand this window, right, as we do these operations. Okay. Okay, we start here from let's say that current is low minus 1 all the way to the left, include any number that is greater than mean, right? So let's say A, B, C. For example, here is D, E, F, X, Y, Z, right? So here is a number between low and high. We start from C all the way to the left, right? And because this section is sorted, we all already know that this is sorted, right? So we know the mean of these sections. When I start from here, we try to include any number that is greater than mean here, right? Group any number that is greater than mean here to this smallest window, right? And stop when the current num is less than mean, right? And why do we stop? Because this is sorted, right? And if the current number, for example B, is less than the mean, it means that the number before A also less than the mean, right? So as long as, let's say, we need to check here. Here the current index should be greater than or equal to 0, right? And the current number, which is array dot current, right? If it is greater than the mean, it means I should include this one to my smallest window. It means that this is this current number is in correct order, right? We want to include it here just by expand the size of smallest window. So when this is not true, we will not exit. Okay, do the same with here. Let the current will be from high to, another thing that is missing here is that we need to move this pointer when it to move on to the next number. So current is high plus 1. As long as the current is still less than the array size, then we want to and the current number is less than the max, right? Which means we have this number is incorrect order. We want to smallest window here, increase the size. Also, we move to the next number, right? So at the end, we return smallest window. Okay, our current state. Whoops, what is wrong here? All right. Let's see test. Why do we have only one test here? Okay, we have 4 passing tests. Awesome. So just to double check a bit here. Okay, so I think that is it for this program. So thanks for watching. See you in the next video.